And okay. Yep. So that's a continuation of the last week. Okay. Example 9-4. Example 9-4. Okay. 9-4. Work out in this case, in this example, sigma 1 and sigma 2 are both unknown. Okay. We are interested in comparing the mean sick days for men and women in a year. Okay, man worker and then women worker sick days in a year. So that's what we wanted to compare. Okay, U1 equal to U2 or not. Okay, and now we first convert the setting hypothesis setting into mu1 minus mu2 equals 0 or not 0. Okay, if we wanted to compare mu1 and minus mu2, we can hey, this is unknown and so is this, and neither is so is this unknown. Okay, and if we wanted to compare mu1 and mu2, we can first calculate x bar and y bar, because by the law of large number, mu1 will be very close to x bar, and mu2 will be very close to y bar. Okay, if N1 and N2 is large enough, but in this example, N1 and N2 are not large enough. Okay, so this is not a good example. All right. Here. Oh. Oh, okay. And the test statistic is not only, does not contain only x bar and y bar. We have to standardize. -0 and 0 is the value under the assumption of null hypothesis. 0 is the assumed value in the null hypothesis, right? Okay, and standardize divided by the standard deviation of x bar minus y bar. Here it is m1 s1 squared and 2s2 squared. Okay, and the statistics is 1.972. So t here is 1.972. Hey, now it is the moment of truth. For the moment of truth, we needed to look for the critical values from the t table. T table involves the degree of freedom. In this example, degree of freedom is the minimal value of n1 minus 1 and n2 minus 1. Okay, so n2 minus 1 is smaller. So the degree of freedom is 6. And then the table, from the table, we obtain the critical value 2.447. And hey, this is the two-tailed test. So we have to see if it is smaller than minus 2.447, because it is the two-tailed test. Okay, or is it bigger than 2.447? Okay, none of these two inequality hold. None of the two inequality hold. So this value, the t value here, does not lie in the critical region. So we do not reject at the level, reject the null hypothesis at the level of 0.05. Okay. You got it? And now what is this? What is this? This is TDF 0.2 divided 0.05 divided by 2.
What happened to my pen? What happened? Okay, where df is the minimal value of 9 minus 1 and 7 minus 1. Okay, so it is 6. Right? Got it? You got it? So that's for the test. That's for the example 4-9. Okay, so let us use another approach, the p-value approach. What about the p approach? Here. By the p-value approach. Okay, we can also approach it is an alternative method. Okay, an alternative method. All right. By the Excel function. The p-value in this example that corresponded to t equal 1.972 is A. Let's go to the A. If you insist on using, the p-value approach, you need to the p-value not available from the table. It's available by the from the Microsoft Excel. Here. Okay, here. Let us look for the p-value. Hey, here, function, insert function. Insert function, where is the function? Where is the function? Hey? Hey? A formula. Insert function here. Statistics. Go to, okay, the statistic and go to t-value. T. Okay, t distribution, t inverse. Is it t distribution? Let me see. Turns left-tailed student t distribution. Two-tailed student t. Left tail. Okay, left tail. Inverse. Is it inverse? Probability. Oh no, not this one. This one. T inverse. T distribution here. Okay. One. What is it? Hey, what is it? Oh, what is it? 1.972, 1.972, 1.972. Degree of freedom is 6. Commutative, logical, yes. True. Yeah, true. One side. Hey, what happened? Oh yeah, here. So, yeah. Okay, here. If you wanted to use the p-value approach, then you have to use the Microsoft Excel. Here. Is p-value equal 1 minus t distribution dist 1.972 6 and true. Okay, which is equal to 1 minus 0.951958. So it is roughly 0.048 0.42. All right. Yeah. So it is 0.048. Okay. This is the p-value approach. Yeah. So, and unfortunately, the p-value. So p-value is what? What is the value of p? 0.048. 0.048. This is bigger than half of the level of the significance, 0.025. So the evidence is not strong enough to reject the null hypothesis. Okay, not strong enough. Oh. Right. Got it? Any question? That's the p-value of problem. Right? What it is. No. Hey, note that the p-value for the t-test Hey, note that the p-value for OT test are not available directly available from the table. We have to use statistical software to get it. Okay? But p-value for z-test can be found in the z-table. Okay? All right? In the z-table. Got it? Got it? So, do we have any question? Because the p-value for the t-test, in fact, for all t-tests, are not available from the t-table. So if you wanted to obtain the p-value, you have to use the Microsoft Excel function. In this example, we use t-distribution. Hey, the p-value here, the test statistic here, the degree of freedom here, and hey, this is default. You have to use it. True, default. Okay, not negotiable. You have to use it. Just use true. Don't use false, and then you will obtain the cumulative probability. And one minus the result is the p-value. So in this example, p-value is 0.048, which is much bigger than half of the level of significance. So the evidence is not strong enough. Okay, if you wanted to reject the null hypothesis, the p-value has to be smaller than alpha divided by 2. Okay, alpha over 2. Okay, half of the level of significance. So the p-value is too big, not small enough. So the evidence is not strong enough to reject the null hypothesis. Understand? So that's the end of this example. Any question? Any question? Do we have any question? If you don't have any question, then I will proceed to the next example. All right. Next example. Yep, this one. Which page? Okay. Now let us go to the next new subsection. 9S. Testing the difference between two mean with dependent sample. Okay. And now suppose mu1 and mu2 are
Okay, the mean IQs of twin brothers or sisters. Hey, remember the paired sample. Paired sample. Okay, because twin brothers and sisters come in pairs. Understand? Okay. Okay, the mean cholesterol levels before and after a diet program. Okay. And then the mean blood pressures of patients before and after medical treatment. Okay. So the IQ, if you wanted to compare them, you have to have X1 and X1 and Y1. The first twin brother or sister, and X2, Y2, the second twin sister or brother's IQ. Okay, so they come in pairs. The IQ value, the IQ score comes in paired form. Okay, so Xi and Yi are always, in this example, will be always dependent. So the t-test that we used before is not suitable for this kind of comparison. Not we need a new test procedure to compare mu1 and mu2. Okay, because hey, mean blood pressure of patients. So Xi and Yi in this example should be the blood pressure you observe on the same patient before and after he or she takes the medical treatment. Understand? So before and after must be before and after the patient, the very same patient. So Xi and Yi must be. Okay, so the old t-test to compare mu1 and mu2 is not suitable for this kind of comparison. So let us see how to do it. Okay, the samples that serve to test the difference, between mu1 and mu2 must come in paired form, like Xi, X1, Y1, X2, Y2, and Xn, Yn, where Xi, Yi are each, for example, the IQs, okay, are dependent. Okay, are not dependent. There are, for example, the IQ of the twin brothers or sisters, and thus are dependent. Yeah. Okay. And if you have X1, Y1, okay, X2, Y2, all the way to Xn, Yn. Now, the first thing to compare mu1 and mu2, okay, to see the difference between mu1 and mu2, the first thing to do is to obtain the difference. Xi minus Yi. Younger brother's IQ minus the older brother's IQ. Younger twin brother's IQ minus the older twin brother's IQ. So you have DI. And then once you have D1, D2, D3, all the way to Dn, then you can factor this. It is not to be used anymore. All you need to use is DI. Okay? And then you calculate the mean value of D. DI, and also the standard deviation of this DI. Okay, and hey, this is what we have learned before, like last semester or earlier in this semester. Okay, and now what is the test statistics? The test statistics here is the division rule, the rejection region, or the critical region for three hypothesis setting are summarized below. Okay. Three hypothesis setting. The first setting, the second setting, the third setting. Okay. The first setting is the right tail test, one-sided test. Second setting, left tail test. Left tail test. Okay, left-sided test. Okay. And the third one is the two-sided, two-sided. Okay. And this is the critical region or the region to reject the null hypothesis. The critical region for the second hypothesis setting. And this is the third region, critical region. Hey, union means either this happens, either this inequality hold or this inequality. Then you have to reject the null hypothesis. Okay? Either or. And don't forget to divide the level of significance by 2. You use only 1/2 of the level of significance. All right? Okay. Understand? So that's is it very similar to what we have learned from the one parameter case? One parameter case mu. Hey, let's go back to the the one parameter case. Right?
One parameter case. Here. Is it very similar? Yeah, very similar. You see this?
And all you need to change is to replace this part by d bar. Understand? And replace is by x sub d. You just add a d here. And also replace mu 0 by the difference under the null hypothesis. Right? Hey. Replace mu 0 by the mu d, which is the difference between mu1 and mu2 under the null hypothesis. Hey, what is the mu d under the null hypothesis?
What is it? Mu d here under the null hypothesis is a 0.
The mu d here, hey, is 0 under the null hypothesis. So, hey, you see that it was mu 0 here, but in this example, in this t-test, we replace mu 0 by mu d under the null hypothesis. But in the null hypothesis, mu d is assumed to be 0, so we put 0 here. Okay, 0, and hey, this is also contain 0. This null hypothesis also contains 0, so it is always it is all zeros in 3 settings. Hey, -0, -0, -0, and it was as far in the previous test procedure, right? But here we replace X by D. Okay, and here, hey, it was S in the previous test. But now we use SD. Is it very similar? It's very similar that you want yeah. Well, is it very similar? What? Here, the procedure, the decision module very similar to what we have learned before for the t-test. Understand? Okay. Now, let us look at it here. Big example, cholesterol level. Dietitian, how to pronounce it? So we how to pronounce dietitian, dietitian 营养师 how to pronounce it? Let me Google. Dietitian. 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 Oh, dietitian. Yeah, dietitian. Huh? Dietitian. Oh. Dietitian. Yeah. That's why I feel strange. What? What is it? Dietitian. Sorry. Dietitian. Hey? Where is it? Where is my, oh, here. Yeah, here. Dietitian, sorry. Huh? I know. Dietitian. Dietitian means an expert on expert of nutrition, food nutrition. Okay, and they makes proposition on for food. Yeah, here. And here, yeah. A dietitian wishes to, oh, what happened? Hey. A dietitian wishes to see if a person's cholesterol level will change if the diet it's a supplemented by a certain mineral. Okay, 6 randomly selected subjects were pretested and then took the pretested. Okay, the pretested what? Pretested cholesterol level before the diet program. Okay, and then took the micro supplement for a 6-week period. Okay, and the results are shown in the following table. Subject 1, subject 2, all the way to subject 6 because there are 6 subjects. Okay, and before they provided they were providing the micro supplement. they have a test of cholesterol level, which are 210, 235, all the way to 244. Okay, and then after they took the after they took the micro supplement, then their cholesterol level become 190, 170, all the way to 228. Okay, so this is X1, Y1, X2, Y2, X3, Y3, X4, Y4, X5, Y5, X6, Y6. So it is Xi, Yi, and their difference are Di. Okay, you want to all the way to B6, and we have once we have these two rows of values are not needed anymore. Okay, so have you break, and we will finish this next hour. Okay.
And now it is time to go to the T table. It is now time to go to the T table. Okay? And this is the also tutorial. Okay. So don't forget to don't forget to divide your level of significance. Divide by 2. Right? So what is the critical value? The critical value here is so, and this is the null hypothesis and the alternative hypothesis. The T value here is 1.610. It is neither bigger than the critical value, nor it is smaller than the minus critical value. The decision here is not to reject the null hypothesis at the level. Hey, here the level is 0.1. So the table you need to go to is the column with 0.05. We will go to the table later. Okay, since the t-test value T 1.610 is not in the critical region. Okay, and now let's go to the table for this value. Test the value. Here. T table. T table is here. This one. Zoom in. Yeah, this one. 0.05 because it is a two-tail test. And alpha is 0.1. Alpha is 0.1. So alpha divided by 2 is 0.05. And the degree of freedom is 5. So 1, 2, 3, 4, 5. So this is the critical value. 2.015. Okay. That is why the critical value here is 2.15. 2.015. Okay. Yeah, here. What? This one. Yeah, this one. Right? And now, so that's the end of the that is the end of this example. That's our decision not to reject the null hypothesis. Right? The question? Do you have any questions? We are now turning to a logical issue, logic.
a logical union. Okay. If A implies B when A is true, then B must be true. Okay. Hey, B's proposition is the same as if B is not true, then A is not true. Okay, if B not B implies not A. Okay. Example: if John falls from the top floor of 101, heavy 101, you know heavy 101? So here you know heavy 101? You know what happens when a man falls from the top floor? He must die, right? No fusion, no parachute. Okay? Just one. Okay? All by himself. Just no fusion on the ground and no parachute on his back. Okay? You'll just go. Okay. If John falls from the top floor, and this is A. This is A. Then B. B is John, guys. Okay? Okay. Then we can also then when you see John alive, John is not alive. Then he goes to the top floor of having 101 and fall from the top floor. No. Because you said if he falls from the top floor, then he will die. Definitely, absolutely. Okay? And if John is now alive, okay, then it did not fall from the top floor of everyone. Okay. So A implies B, and not B implies not A. That's the logic, right? A implies B. Okay. Then can you say B implies A? No, you cannot say B implies A. When A implies B, the direction is A to B, but you cannot say B implies A. But you can say not B implies not A, right? That's the logic. Okay, not B. Then John is not alive. Then John did not fall from the top floor of everyone one. Okay. Okay. If you insist, hey, B implies A, then let me ask you, hey, John dies, not John dies, if we have it, right? So you must went to the floor of every 101 and then fall from it. No, the dies maybe be too many, too much sleeping view. You know, sleeping view here. I mean, yeah, too much. They only find himself at the risk. Right? And you know what I'm saying? What did I just mean? But what? About how about John dies? So he must hold on one died because the reason he dies can be he communicated sleeping pills or just like you or the guy in the car accident. Not necessarily go from everyone. So B, that's not always the by A. Understand? But you can say not B implies not A. You cannot say B implies A. You can only say not B implies not A. You understand? So what is the big deal? What is the big deal about this? Does it have much to do with the hypothesis and statement? Yes, it has much to do what we conclude for the hypothesis testing. All right. Here. Now let's turn to the hypothesis testing. And if H0 is true and B is A is true, then B is. Okay, if mu A, the null hypothesis states that mu smaller than 0 is true, and this is now it is true, then B is true. Then X bar should not be bigger than C by too much for some C bigger than 100. Okay, so A implies B. If A is true, then X bar should not be too much bigger than C for some C bigger than 100. Okay? Because mu is smaller than 1. Then X bar cannot be bigger than 100 by too much. And why? Because by the law of large number, hey, mu and X bar are very close when n is large. Understand? So when mu is smaller than 100, then so is X bar. X bar should be also smaller than 100. And it should not be bigger than C by too much. Okay? For some C. Bigger than 100. Now, conversely, now if not B, if it is too big, not B, then we should conclude not B. Understand? When not B happens, we should conclude not B. What is not B? Hey, not A is means that 0 is false. Because not B occurred, then we should conclude not B. So not B implies not A. This implies H0 is false. So we should reject the null hypothesis when this is too big. Understand? So this is why and accept H1.
And this means we should accept H1. Okay? We should accept. Right?
That A implies B. We can when A always implies B, then if we see not B, what should we conclude? If you see not B, then what should we conclude? Not B. Can we? And okay, another issue. When we see B is true, can we conclude A? No. No. Okay. So this is when B happens. When B happens. So okay. This is not too big. B holds. We should not conclude B. Can we conclude A is true? No. No. We don't say. So we don't say this is true. We don't say we don't have strong evidence. We don't have evidence strong enough to reject the null hypothesis. You should not say B is true, but you should not say H0 is true because you see B, when you see B, you cannot conclude A. all you can say is that because B, when B is true, does not necessarily implies that A is also true. So when these happen, and this is B, this is B, we do not conclude A. We don't say, oh, X0 is true, we accept this hypothesis. We don't say. Well, what should we say? Okay, we don't conclude accept X0. We often say do not reject X0. Okay, that's the wording. That's the wording for hypothesis testing. When you do not, when it does not lie, when the C does not lie in the critical region, what should we say? We don't say accept X0. We say we don't have much evidence. We don't have the evidence strong enough to reject the null hypothesis. We don't say. We don't say. Okay. When you say, oh, accept X0, this means that you see B hold it and you conclude A. No, you cannot do it. You should say we do not have evidence to conclude nothing. Okay, so we don't reject the null hypothesis. That's the wording, okay? That's the wording we should use. Understand? You know wording? Wording means right? What? Wording. That's what we should say. When B hold, when B hold, we don't say A hold also. When B hold, we don't say A hold as well. Because A implies B. When A implies B, we should not say A hold when you see B also. Okay. So that B, when B is true, does not necessarily implies that A is true. So when B is true, we do not say A is also true. We just say we don't have evidence strong enough to deny it. Okay. So we do not reject the null hypothesis. Right? Any question? If you don't have any question, then we will proceed to the proportion comparison. And here it is the comparison of U1 and U2. Based on still and the sample. Okay? That's the end. We have finished. We have finished. Okay? And then we should go to the next step segment. Comparison of proportion. Two populations proportion. Okay? Two populations proportion. Right? And now let me add this slide into your slide. Okay? Hey, this is the other classic slide. And I want to add that into your slide. Okay? So please give me some time. Just give me some time, okay? Give me some time. Say from this page. From this page. Eh? What? Oh yeah. From this page. Yeah, from this page. 53 to 61.
53 to 61, 53 to 61, yep, here. 53 to 61. Yeah, 53 to 61. Yeah, this one. This one. Here. BA yesterday. Yeah, this one. 53 to 61. Yeah, wait a minute. Wait a minute. 58 to 61. Wait, what is it? Here. Yep. 53 to 61. Yep. 53 to 61. 53 to 61 here. 53 to 61. 53 to 61. Yeah, here. Okay. Here. Yep. $53. Yep, here. This one. This one. This one. And 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 this one. Logical issue. Yeah. Okay. Yeah. Hey. I think I missed one. Hey, what happened? BA. Oh, this one. Which one? Oh, last page. Last page. copy and paste. Yep, this one. Okay. Yeah, this one. Yeah. Okay. Next section. Next section. To compare the population proportion. Population proportion. Hey, the procedure for testing the P1 and P2, hey, population proportion is a little bit different from what we have learned previously. So let's go to chapter 9, comparison of population proportion. Population proportion. Yeah. 9-5. Okay. Testing the difference between proportions. P1 and P2. Okay. Okay. Imagine that. What happened to my pen? What a shame. 讨厌。One seek to compare the proportion of the nearsighted student in TKU and Althelia University. All right, Althelia University. Okay, and the P1 and P2. Okay, and then he or she can respectively select randomly, and randomly select N1 and N2 students. Respectively. From TKU and AU. Okay? And let xi equal 1, 0. Okay? If I TKU student is nearsighted. 近视眼 if the ITKU student has healthy eyes. Okay? And let what happened? And then, and yi equal 1 over 0 if the J AU student is nearsighted. And 0 if the J has healthy eyes. Okay? And then by the law of large number, by the law of large numbers, X bar will be very close to P1. Y bar will be very close to P2. So we can compare P1 and P2 based on X bar and Y bar. Okay. So to test, at 0, P1 equal P2, or at 0, P1 minus P2 equals 0. Okay, we can use the Z statistics. Defined by, hey, here, hey, Z statistics, hey, X bar minus Y bar, all right, minus P1 minus P2 under the null hypothesis divided by A N1 sigma 1 of X sigma 1 of Xi's plus N2 sigma 2 of Yi's. Understand? Hey, so this is minus, hey, minus 0 because under the null hypothesis it is 0. And N1 P1, 1 minus P1, plus N2, P2, 1 minus P2. Okay? You see that? But this formula is not good enough. P1, 1 minus P1. P2, 1 minus P2. The formula is not good enough. Why? Because under the null hypothesis, P1 under the null hypothesis, P1 and P2 are equal. So they have to use but under the null hypothesis, P1 equal P2. So we have to the same T for both PKU and AU, because in the under the null hypothesis, P1 and P2 are equal. Okay? That is, we should use the same, we use a common value of P. Okay? We should a common value of P. Understand? Okay. So there should not be subscript. There should be no subscript here. No one in a subscript, no one here, no two here. We have to use the common value. We have to use the common value for both PKU and AU, because under the null hypothesis, hey, under the null hypothesis, they are the same. So we should use no subscript here and give them a common value. Okay? A suitable candidate for the common value is given by, hey, P hat equal N1 minus N2. Okay? And X1 plus X2 all the way to Xn, N1 plus Yn2. All right? Given by P hat. All right? P hat. That is, we pull them. we pull them together. We put them in a sentence. We ask even, okay, the common value of P. To obtain the common value of P, right? To obtain the common value of P. Let me explain why like. Okay, so the test statistics becomes this is a suitable formula. B, all right, equal x bar minus y bar minus 0. A, N1, P1, 1, oh, no one, no subscript here. Sorry. P hat 1 minus P hat plus N2 P hat 1 minus P hat. Okay, then it is equal to, hey, here it is P1 hat P2 hat minus 0. No 0 here. Okay, no more 0 here because it's the same to write the formula without the without 0, without minus 0. Okay, please go to the textbook, chapter 9. Please go to page what? Oh no. Yeah. Please go to page 514. Page 514. All right. So this is P hat. Oh. Let me use the textbook's notation. I will explain next week. Okay. P hat, P bar, P bar, P bar, P bar, P bar, P bar, P bar. Okay. All right. And here also P bar. Also P bar here. Okay, here. And equal. P1 hat, P2 hat, square root of P bar, Q bar, 1 over N1 and 1 over N2. Same thing. So that's the formula in your test book. Okay. Okay. What time is it? 2 minutes to 12.
Okay, local time. Local. We will be back on this. Hey, we will be back on this. And this, why we can pull it together? Why can we pull them together? Why should we pull them together? Hey, put them together, all together. Hey, all of them. Hey, M1 plus N2 student of TKU and AU, put them together to obtain the common value of B. Okay, local time. The attendance is getting worse. It will stop. The absence is good. And you don't pass the post mention. Because you have only 5 things. This one. 3 seconds, 4 seconds, 5 seconds. Okay, that's it. Hey. Raise your hand if you miss it. Okay, come to me.
Or later. After I upload the slide.